Dear friends, Maths Aspirants is a collective of mathematics students, research scholars, and faculty members across India, initiated by myself in 2017. We used to arrange several online problem solving sessions to help the students who prepare for different national level competitive examinations. As a part of that series, today we have a session on numerical analysis, and Mr. Muhammed Rafeek, research scholar, Central University of Karnataka, is with us to discuss some problems from the area of numerical analysis. As all of you know, the NET examination is very near. So today, in today's session, Mr. Rafeek will concentrate on the previous year problems from the areas of numerical analysis. I'm sure that today's session will be really helpful in your final round preparations for CSER NET examination. I would like to thank Mr. Rafeek for accepting our invitation and engaging this session for all of you today. I welcome everyone to this program. Welcome, Rafeek.
Good evening, all, and thank you, sir, for this kind invitation. And this is a great opportunity to me in this such a wonderful platform, our Max Experience Group. And this is my second class in this this great platform. For that, I am giving thanks to our sir, Vinod sir, and very thankful for this invitation. So today I am going to discuss the numerical analysis. We know that every year we have several problems in CSIR, NET or GATE exam. We have the questions from numerical analysis. So let us see some of the problems in the numerical analysis section. These are some of the questions. This is already our sir is put in our WhatsApp groups or and Telegram groups. So just see that problems. This is very helpful to you. Yeah. First, I am going to read the first problem. Consider the numerical integration formula. Integral -1 to 1 f of x dx approximately equal to g of alpha plus g of negative alpha. For alpha is equal to 0.2 all raised to 1/4, which of the following statements are true? Yes, these are the options. Yeah, it is visible to everyone?
Yes, sir.
Okay, thank you. Okay, yes, anyway, this is a question. You can read the question within 1 or 2 minutes. This is now your time. Just read the questions. One or 2 minutes you can take, and if you know, you can comment your answers also in our chat box. Now is 7:07. Just I am giving the 2 minutes for reading the question, and if you know, you can answer also. Just comment your options in our chat box. Anyway, this section I am, let us see. We are in the final stage of our preparation. So just focus on your answers also. So this time is 1.5 or 1.5 hours you can take for a preparation, final preparation. So don't think this is a class. This is a think that this is some workout problems in your final section. Okay, the first question, time is over for reading. Yeah, see the options. Consider the integration consider the numerical integration formula. Integral -1 to 1 f of x dx approximately equal to g of alpha plus g of negative alpha. For alpha is equal to 0.2 all raised to 1/4. Which of the following statement is? See, all the options have the a plus bx form. This answer, I'm going to give some shortcut method. See, all the formula, all the options have a plus bx form. See, option A have the a plus bx, and option B a plus bx plus cx square is there. And similarly, cx square plus dx cube is there in the option C. Option D, cx cube plus dx raised to 4 also there. So anyway, all the options have a up to a plus bx. Now let us try with f of x is equal to x square. Okay. Let us see f of x is equal to x square. Then what will happen? Then let's see, integral minus 1 to 1 f of x dx become equal to we know that integral minus, just I am going to take f of x is equal to x square. Integral minus 1 to 1 x square dx, that is equal to 2 into from the fundamentals of integration, because x square is an even function, x square dx, that is equal to 2 into x cube by 3 from 0 to 1. Then it become equal to 2 by 3. That is the LHS of this integration formula. And what about right formula? G of alpha plus g of negative alpha. And approximately we have taken that is an x square. So our f of x is x square. So it become equal to alpha square plus alpha square. So this become equal to 2 alpha square. So approximately what you are getting? 2 alpha square is equal to 2 by 3. Then 2 cancel. Alpha square is equal to 1 by 3. Alpha is equal to square root of 1 by 3. But alpha is given as a 0.2 all raised to 1 by 4. So wherever x square is there, that option is incorrect. The alpha they are given such as 0.2 all raised to 1 by 4. We got here square root of 1 by 3. That is not equal. So option B is incorrect and option C also incorrect. But there x square term is there. Now let us see the f of x is equal to x raised to 4. Let us try with that. See, f of x is equal to x raised to 4. I am going to see. Then integral minus 1 to 1 f of x dx. That means x raised to 4 dx will come. That means integral minus 1 to 1 2 into, okay, x raised to 4 dx. That means 2 into integral 0 to 1 x raised to 4 dx, because again is an even function. In that time you will get 2 into x raised to 5 by 5 from 0 to 1. That you will get 2 by 5. 2 by 5 approximately equal to g of alpha plus g of negative alpha. Alpha raised to 4 plus minus alpha all raised to 4. It means 2 alpha raised to 4. That means 2 cancel. Alpha raised to 4 is equal to 1 by 5. 1 by 5 means 0.2. Alpha is equal to 0.2 all raised to 1 by 4. Exactly correct. That is the given value of alpha. So, of course, option D is correct. With x raised to 4 is correct. And all have a plus bx form. Option, let us verify that. You can verify in your own time. So this form is correct. So option A correct. Option B including x square. So that is incorrect. Option B is incorrect. Option C also including x square. Option C is incorrect. Option D is correct. There is no x square and there is a term of x raised to 4. So option A, comma, option D is correct. This just I am gone through a shortcut method. I think it is clear. Is it fine?
Sir, is there f and g are same?
F Once again, yeah, this is we are treating with approximate, right? We are treating with approximation. So at the time you can take as a same only. Wherever you are taking f of x, at the time you can take f1g as same only, because this is approximation. Quadrature formulas, right? You can go on through the same only. You can take it same. No issue. Got it?
Okay, sir.
Yeah. So option A, comma D are correct. Anyone got this that options? Anyone? Okay. Let us read the next example. Let us read the next example. Can anyone read that question? Can anyone please? Okay, otherwise I will read it. And everyone have the questions, right? Okay. Is it visible? Questions are visible?
Yes, sir.
Yes, sir.
Okay. Yeah. Consider the Newton-Raphson method applied to the approximate the square root of a positive number alpha. A recurrence relation for the error En equal to xn minus root alpha is given by En plus 1 is equal to 1 by 2 En plus alpha by En. En plus 1 is equal to 1 by 2 En square by En plus root alpha. Option 3, option 2. Okay, En plus 1 is equal to 1 by 2 En minus alpha by En. Option 4 is En plus 1 is equal to En square by En plus 2 root alpha. Okay, anyway, this is a time for reading. Yeah, let us go to the answer. You see, consider the Newton-Raphson method. Okay, my board is visible, right? Board is visible?
Yes, sir.
Okay. Yeah. Consider the Newton-Raphson method applied to the approximate the square root of a positive number alpha. So that means you need to see x square equal to alpha. Then x is equal to root alpha, you will get it. X is equal to root alpha, you will get it. That is the question. So let us take this as a function in f of x. F of x is equal to x square minus alpha. Or f of x is equal to, you can take x square equal to alpha means x equal to root alpha. So x minus root alpha is equal to 0. You know the basics of Newton-Raphson method. We know the formula of the Newton-Raphson method. Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So you have like this xn minus xn square f of xn become equal to, you can take x square minus alpha equal to 0. That means xn square minus alpha is equal to 0. F of xn become xn square minus alpha divided by f dash of xn. 2xn you will get it. That equal to xn minus xn square by 2xn, xn by 2 minus minus plus alpha by 2xn. Alpha by 2xn. That means you have the formula for xn plus 1. Xn plus 1 is equal to xn minus xn by 2, xn by 2. 1 by 2 xn plus alpha by xn. That is the formula for xn plus 1. And you know The formula for error function En equal to error is nothing but xn minus the accurate value is root alpha. So exact value is root alpha. So xn minus root alpha. That is the error. So En plus 1 is equal to xn plus 1 minus root alpha. Xn plus 1 minus root alpha. We need to find the formula for En plus 1. Then already we have the formula for xn 1 by 2 into xn plus alpha by xn minus root alpha. You take it 1 by 2 as a common. Xn plus alpha by xn minus 2 root alpha. From that 1 by 2 xn, there is 2 root alpha, take it 1 root alpha plus alpha by xn minus root alpha. Xn minus root alpha is nothing but En. 1 by 2 En plus alpha xn, En equal to xn minus root alpha. So xn equal to En plus root alpha. En plus root alpha is nothing but xn. Put it there here. En plus root alpha minus root alpha. Just work out it there. En plus root alpha you can take as a LCM. En plus root alpha you can take as a LCM. En into En plus root alpha. First term become En into En plus root alpha plus alpha minus root alpha into En plus root alpha. Work out it. Then what you will get it? That equal to 1 by 2 En into En square plus En root alpha plus alpha minus En root alpha plus minus root alpha into root alpha is nothing but alpha. En root alpha minus En root alpha. Alpha minus alpha divided by En plus root alpha. That means 1 by 2 En square by En root alpha. Which is option? This is the En plus 1. So, which one is the correct option? Tell me. Tell me which is the correct option?
Sir, what is the third one?
Third one, correct. Yeah, tell me. Tell me your doubts. Hello? Is it clear? Is it clear? Okay, let us move to the third problem. Can anyone? Okay, I will read the problem. Okay, this is clear. This is clear. Can I rough it? Okay, we will rough it then. The values of alpha. Let us read the next problem. I think you have the problem. The values of alpha, comma A, comma B, comma C for which the quadrature formula integral minus 1 to 1 minus x into f of x dx is equal to 1 minus x into f of x dx is equal to a into f of minus alpha please plus b into f of 0 plus c into f alpha is exact for polynomial of highest possible degree R. Okay. Let us see the options I have. Not going with the options. Options, you have the options. Okay, yeah. First, I am going to see the f of x is equal to 1. Whenever you are giving quadrature formula, you take f of x is equal to 1, f of x is equal to x, f of x is equal to x square, like that. So first I am going to see f of x is equal to 1. So what will happen? Integral minus 1 to 1 minus x, f of x is 1, so 1 minus x dx equal to, so that is, you can find integration of this x minus x square by 2 from minus 1 to 1. If you give 1 minus 1 by 2 minus minus 1 minus 1 whole square is 1 by 2 only. So finally you will get 1 minus 1 is 2 minus 1 by 2 is become 0. So 2 is your answer. 2 equal to, now you give the right hand side, f of x is equal to 1. Then what you have? A plus a into f of minus alpha means 1 only, because f of x is 1. F of 0 also 1. A plus b plus c. So this is the equation number 1. A plus b plus c is equal to 2. Okay. And it is clear. From the option it is clear. B equal to 8 by 9. That is clear. Put it here. So what you will get it? A plus c is equal to 2 minus 8 by 9. 10 by 9 you will get it. No need to check B. B already clear. All the options C. B is equal to 8 by 9 only. Now let us take f of x is equal to x. Then integral minus 1 to 1 minus x dx. That is nothing but integral minus 1 to 1 x minus x square dx. See, that is nothing but x square by 2 minus x cube by 3. The first one is an odd function. That becomes 0 only. 1 by 2 minus 1 by 3 minus 1 by 2 minus 1 by 3 equal to 1 by 2 minus 1 by 2 0 minus 1 by 3 minus 2 by 3. You will get it minus 2 by 3. Now right hand side. Yeah. Right hand side what will have? A into f of minus alpha. So a into f of x is x only. So a into minus alpha plus b into f of 0 becomes 0. C into f of alpha, C alpha. So minus A alpha plus C alpha equal to minus 2 by 3. Yeah. And first how A plus C is equal to 10 by, this is equation number 1. This is equation number 2. Multiply the first equation with the alpha. What you will have? A alpha plus C alpha equal to 10 by 10 alpha by 9. Add these two equations. Minus alpha plus A alpha 0. 2C alpha. You add these two. 10 alpha by 9 minus 2 by 3. Then C equal to 2. Divide with 2 alpha. 10 alpha by 2 alpha, 10 by 18. Alpha alpha got cancel, 10 by 18 minus 2 cancel, 1 by 3 alpha. 5 by 9 minus 1 by 3 alpha. I think the value of alpha also equal. All the option alpha also equal. Root 3 by 5. Alpha equal to root 3 by 5. Root of 3 by 5. Okay, put it here. So 5 by 9, 1 by 3, reciprocal of that. Root 5 by root 3. That means the value C 5 by 9 minus root 5, 3 root 3. Yeah. Take, I'm going to arise here. See the options. Alpha is already there given. C equal to, take it 5 by 9 as a common. Then 1 minus 5 you are taken as a common. Okay. Already you have root 5, 3 root 3. 5 by 9 you are taken as a common. So 9 by 5. You should multiply with 9 by 5. So 5 by 9. 1 minus root 5, 5 cancel. 3, 3 cancel. So 3. Okay. Wait. 3 root 3. So finally you have root 3 only. Root 5 cancel because root 5. 9 and 3 root 3 cancel because last root 3. Yeah. Root 5. 5 by 9 into 1 minus root 3 by root 5. I think which option have that? All option alpha is root 3 by 5. No need to check. All option B equal to 8 by 9. No need to check. C 5 by 9 minus root 5 by 3 root 3. 5 by 9 minus root 5 by 3 root 3. Options B 2 is incorrect. Option 1 may be correct. Option D also may be correct. 5 by 9 into 1 minus root 3 by root 5. So option 2 is incorrect. Option 3 is incorrect. Only may correct 1 or 2. Now need to check the value of A. Let's find the value of A. Because we have A plus C is equal to 10 by 9. A plus C is equal to 10 by 9. By using that. A plus C is equal to 10 by 9. Correct. C already now we have. A is equal to 10 by 9 minus 5 by 9 plus root 5, 3 root 3. Okay. The first two term you can easily subtract it. 5 by 9 root 5, 3 root 3. Take it 5 by 9 as a common. 1 plus same root 5, 3 root 3 into 9 by 5. If you multiply it, you will get 5 by 9 in 1 plus root 3 will come divided by root 5. So which option is correct? root 5, 3 root 3. Yes, option 1 is correct. 5 by 9 into 1 plus root 3 into root by 5. Option 1 and 4 is correct, right? Yes. Yes or no? Tell me. Tell me, option 1 and 4 is correct, right? Please respond. Hello.
Yes, sir.
Yeah. Is it clear, right?
Yes, sir.
Okay. Yeah. Okay. We will move to the next problem. If you have any query, you can ask. You can intercept, no issue. What about next problem? The iterative method xn plus 1 equal to g of xn for the solution of x square minus x minus 2 equal to 0 converges quadratically in a neighborhood of the roots x equal to 2 if g of x is equal. Okay. Yeah, for a convergence of the iterative method, the sequence xn converges with the order q to L. Okay, let us write it there. Convergence of iterative method. The sequence xn converges to L with the order q, with the order equal to q. Of course, for a q greater than 1, you should have limit n tends to infinity modulus of xn plus 1 minus L divided by mod xn minus L whole power q. This limit should be finite. That means it should be less than m for some positive constant, not necessarily less than 1. No need to less than 1. Quadratic means you have the condition like this. Limit n tends to infinity modulus of xn plus 1 minus L divided by mod xn minus L whole power q should be less than m. Now you can verify with the different options. Yeah. Okay. This theory is clear. This is the condition. Limit n tends to infinity modulus of xn plus 1 minus L divided by mod xn minus L whole power q. Q means 2. In this case, q means 2 only. Q means 2. Quadratic. They are given quadratic convergence less than n. Okay, verified fast. Okay, then yeah, first you have to take g of x equal to x square minus 2. I think that is the first option. G of x is equal to x square minus 2. Yeah, of course, L equal to 2. Limit is 2. They are given neighborhood of the root x equal to 2. So L equal to 2. And so limit n tends to infinity xn. That is L. L that is equal to 2. Yeah. So need to find a limit n tends to infinity xn plus 1. What's the formula? Xn plus 1. Xn plus 1, you have the formula. Xn plus 1 for the quadratic, for the iterative method. G of xn, that is you are taken as xn square minus 2 here. The first option is xn square minus 2. So replace it. Instead of xn plus 1, you can write xn square minus 2 minus L. L means minus 2 divided by modulus of xn minus 2, the whole square. Because we are checking the quadratic convergence. Limit n tends to infinity This is xn square minus 4. Xn square minus 4 means xn square minus 2 square. That you can write written as xn minus 2 into xn plus 2. A minus b into a plus b. Modulus of xn minus 2, the whole square. Okay, by the properties of modulus. Anyway, you can written as this, cut it, cancel out it. This, sorry, xn minus 2 and xn minus 2. So finally you have xn plus 2 divided by xn minus 2. See, limit tends to infinity, xn is equal to 2. So above it becomes 4 by 0. 4 by 0 means it is infinity. It's not a finite. So that is incorrect option. Let us go with option 2. Option 2. Yeah, option 2. G of x is equal to G of x is equal to x minus 2 whole square minus 6. X minus 2 whole square minus 6. L equal to 2 only. That means limit tends to infinity. Xn is equal to 2. Similarly verified, everything same. G of xn. That is xn plus 1. That equal to xn minus 2. The whole square minus 6. Find the limit. Limit n tends to infinity. Xn minus 2 whole square minus 6 minus L. L means 2 by modulus of xn minus 2 whole square. If you expand it, you will get like this. Xn square minus 4xn minus 2 whole square plus 4. 4 minus 8. Finally, we get minus 4 divided by. Okay, so this is not like this. Divided by modulus of xn minus 2 the whole square. Just apply the limit. 2 square means 4. 4 into 4. Sorry, 4 into 2 minus 4. Pi anyway 0. Something minus 8 by 0. Again is an infinity. So that option also incorrect. Next. Similarly, you can verify the remaining option also.
Sir?
Yeah. Hello.
Sir, if you just redo the page, that we have the expression as modulus of xn minus 2 whole square.
Yeah, correct. For the quadratic
So,
conversion. Yeah.
Yes. So in the numerator, in the previous option, in the numerator, we have xn minus 2, modulus of xn minus 2 whole square divided by modulus of xn minus 2 whole square. So the limit is become 1.
No, I think no. Option 2 you are telling, or option 1?
Option 2, sir.
Option 2 is modulus of xn minus 2, xn minus xn square minus 4xn minus 4.
Minus 4. If I take the minus in common, we have the modulus. So we absorb it. We obtain that.
Xn minus whole square, what will come?
Okay,
Xn square minus 4xn plus 4 will come, right?
Yes.
Yes,
Okay.
yes.
I make a
Okay.
mistake.
Yeah. Correct. Okay. No issue. Yeah, very good. No issue. Yeah, g of x, third option, g of x is equal to, I think 1 plus 2 by xn, g of xn, or xn plus 1. That is equal to 1 plus 2 by xn. That equal to L equal to 2. Next, L equal to 2. And similarly, as it is, limit tends to infinity, xn is equal to 2. Okay, verify the limit. Limit n tends to infinity. 1 plus 2 by xn minus 2 by modulus of xn minus 2 the whole square. Limit n tends to infinity. Take mod xn as a LCM. So in the numerator, xn plus 2 minus 2xn. That xn you can take as a denominator. Xn minus 2 whole square into mod xn. Then it become xn minus 2xn is limit n tends to infinity 2 minus xn divided by modulus of xn minus 2 the whole square into mod xn. In the denominator minus you take 2 minus xn will come, take it, cancel out it. Then mod anyway is mod limit n tends to infinity 1 by mod xn minus 2 divided by mod xn is 2. Denominator become 1 by 0. Become infinity. Option 3 also incorrect. Go with option 4. It should be correct. It should be correct. Okay, verify it. These are easy calculations with limit. Next. G of x is equal to g of xn, or that is equal to xn plus 1. That equal to xn square plus 2. The last option, 2xn minus 1. Limit n tends to infinity, xn square plus 2, 2xn minus 1 minus 2 divided by modulus of xn minus 2 the whole square. Limit n tends to infinity, subtraction, you will get xn square plus 2 plus 2 divided by xn minus 2 the whole square into 2xn minus 1. Numerator you will have the 4. That is nothing but limit n tends to infinity. That is xn square minus 4xn plus 4. That means xn minus 2 the whole square. There is correct. Xn minus 2 the whole square into 2xn minus 1. These two cancel. 1 by 2 into 2 minus 1. That means 1 by 4 minus 1, 1 by 3. It's a finite value. So this is correct. So this is the option. Am I right? Is it clear now? Am I right? Is it clear? Just understand that formula. That is enough. Clear? Is it clear?
Yes, sir.
Yes, sir.
Okay. Yeah. We will move to the next problem. It's an easy problem. There is a table. Let us see the table. Using the following values of x and f of x, the integral I equal to 0 to 1.5 f of x dx evaluated by the trapezoidal rule is 15 by 16. The value of a is equal to. Yeah, it's an easy problem. Yeah, integral I that is equal to integral a to b f of x dx approximately equal to, we know that formula for trapezoidal rule, h by 2 y naught plus yn plus 2 into y1 plus y2 plus etc. plus yn minus 1. Trapezoidal rule of formula. Yeah, from the table here, clear that h is equal to 1 by 2. They are tracing. F says h equal to 1 by 2. So integral value they are given 5 by 60, 15 by 16. 5 by 16 or 15 by 16? I don't know, it's 15 by 60. Okay, let us see. 15 by 16. That equal to 1 by 2 into 1 by 2. That means 1 by 4. Why not? Why not mean the first value? That is 1. Plus yn. Yn is the last value. That is minus 5 by 4. Plus 2 into y1. Y1 is a. Here only y2. Y2 is 0. See, the first value is y0. Second value is y1. Third value is y2. And the last value is y3. Corresponding x0, x1, x2, x3. 1 by 4. 1 by 4 into 1 minus 5 by 4. Minus 1 by 4. Plus 2a. This you can take 15 by 16 plus minus will come minus 1 by 16. It becomes 16 equal to a by 2. To a by 4. A by 2 will come. 16 by 16 equal to a by 2. A equal to 1. Correct? Any mistake I did? No, no, right? I think that is not a 15 by 16. That is 5 by 16. Do it with that 5 by 16. Okay. Mistakenly is that 5 by 16. If it is 5 by 16, what will happen? LHS become 5 by 16. 5 by 16. Okay. Then up here. Okay. 5 by 4 will come. If this and this cancel, it becomes 5 by 4 equal to minus 1 by 4 plus 2a. Correct. This becomes 6 by 4. 6 by 4 equal to 2a. A equal to 6 by 8. That equal to 3 by 4. Yes. A equal to 3 by 4. Option 1. That is just change it. It's not a 15 by 16. It's a 5 by 16. Okay. Fine. Got it? It's an easy problem. It came in CSIR only. Okay. It is clear? Yes or no? Can I go with next problem?
Yes, sir.
Next, yeah, next problem. This is the next problem. What is the next problem? Yeah. Let A be the following invertible matrix with real positive entries. A equal to 1 to 89. Let G be the associated Gauss-Seidel iteration method. What are the two eigenvalues of G? What are the two eigenvalues of G? Yeah. G be the associated Gauss-Seidel iteration matrix. The formula for G that you just remember it. G equal to negative of D plus L all inverse into U. D plus L. Let us see the D plus L. See, A matrix they are given. D. D means diagonal matrix. From that A. So 1, 0, 0, 9. That is D. L means lower triangular of that. 0, 0, 8, 0. Add these two. So you will have 1, 0, 8, 9. That is D plus L. U means upper triangular of that. 0, 2, 0, 0. This is U. Find D plus L all inverse. We know that formula for A inverse. A inverse equal to 1 by determinant of A into ℕ𝑔. Determinant of this 9 minus 9, 1 by 9. So 1 by determinant of A is equal to 1 by 9. Adjoint of this. You know that. Just change the diagonal entries. 9, 1, ℕ𝑔. How to find the adjoint of 2 by 2 matrix? Just change the principal diagonal entries and change the sign of the off diagonal elements. 0 and minus 8. Multiply to inside. 9 by 9, 1, 0, minus 8 by 9, 1 by 9. That is D plus L on inverse. G equal to minus D plus L all inverse into U. Multiply these two matrices. Minus 1, 0, minus 8 by 9, 1 by 9 into U. U means 0 to 0, 0. Multiply these two. First entry 1 into 0, 0. 2, yes, 2, 0, minus 16 by 9. That is G. Negative is there. So final answer 0, minus 2, 0, 16 by 9. Now you can find the eigenvalues and determinant. Yeah, trace is equal to trace. Trace of this matrix is 16 by 9. So product of eigenvalue is not addition. Lambda 1 plus lambda 2 should be equal to 16 by 9. And determinant equal to 0. Product should be equal to 0. Verify the option. First option, product is 0, but addition not a 16 by 9. Option 1 is incorrect. Option 2 also incorrect. Product is 0, addition is not correct. Yes, option C. Addition is 16 by 9 is correct. Product is 0. Yes. Yes, option C is correct. Is it clear? Is it clear? Can I?
Yes, sir.
Okay.
Yes, sir.
Yeah. Yeah. Next problem. What is the next question? Yeah. Let us move to the next problem. Yeah, we will go with some more 4 problems. Then we will wind up. No issue. Remaining you can do in the problem sheet. Let the solution to the initial value problem y dash is equal to, they are given, y dash is equal to y minus t square plus 1. 0 less than or equal to t less than or equal to 2. 0, t less than or equal to 2. Y of 0 is equal to 0. Sorry, y of 0 equal to 0.5. We computed using Euler's method with steps length h equal to 0.4. H equal to 0.4. If y of 0.8 and w of 0.8 denote the exact and approximate solution at t equal to 0.8. T equal to 0.8. Then the error bound for Euler's method is given by. Okay, we know that the formula for error bound. If don't know, just note down it. Y of ti. I of ti is the exact value. W of ti is the approximate value. Error bound. It should be less than or equal to m into h by 2l exponential l into ti minus a l into ti minus a minus 1. This is the error bound. I will tell you everyone. M equal to, m is nothing but maximum of modulus of y double dash of t. Yeah. A equal to Ti minus A. A and B. A and B here, lower limit and upper limit. A equal to 0, B equal to 2. A equal to 0, B equal to 2. Yeah. L is Lipschitz constant. L equal to maximum of dou F by dou Y. That is nothing but F is the right hand part. Y dash equal to F of X comma T. We will take F of Y comma T. So this is equal to F, right hand side. Differentiate with partially with respect to Y. Maximum of dou F by dou Y. Dou F by dou Y, you will get 1 only. Maximum of 1 is 1. So L equal to 1. Now you need to find the Y double dash. Then only you are able to find the maximum of Y double dash. Okay. Y dash is equal to Y minus T square plus 1. So Y dash minus Y equal to 1 minus T square. This is linear first order differential equation. You need to find the integrating factor. Integrating factor is e power integral P of T into dt. P of T is minus 1 dt. You will get e raised to minus t. Then the solution y e power minus t equal to right hand side integral 1 minus t square e raised to minus t dt. Okay, then plus the constant of integration that equal to integral e raised to minus t dt integral e raised to minus t dt minus t square e raised to minus t dt plus the constant of integration that equal to e raised to minus t by negative 1 minus first into t square into e raised to minus integration by parts minus 1 2t e raised to minus t minus 1 dt that equal to minus e raised to minus t plus t square e raised to minus t plus 2. This minus plus into minus is again negative. 2 integral t e raised to minus t dt. Okay, that equal to in the left hand you have y e raised to minus t. So you divide it. Y equal to divide with e raised to minus t. So minus 1 plus t square. Again, you need to integrate it again. Okay. First integrate it, then not you go with that. Okay, that equal to minus e raised to minus t plus t square e raised to minus t minus 2 into again integration by parts t e raised to minus t minus 1 minus integral of derivative of t is 1 e raised to minus t minus 1 dt. Then you will get like this e raised to minus t square e raised to minus t plus 2t minus plus 2t e raised to minus t, minus minus plus, again integrate it, e raised to minus t, e raised to minus t minus 1, again minus, so plus 2 is there, plus 2 e raised to minus t, plus the constant of integration. Now divide with the e raised to minus t. So y equal to, you will write this, y equal to minus 1 plus t square, correct, plus 2t plus 2 plus c divided by e raised to minus t. That equal to t square plus 2t minus 1. Minus 1 plus 2 become plus 1. T square plus t plus 1. That means t plus 1 whole square. Plus c e raised to minus t. Use the initial condition. Y of 0 equal to 0.5. Then you will get c equal to minus 1 by 2. By using this initial condition, you will get the particular solution. So your y of t equal to t plus 1 whole square minus et by 2. Need to find the maximum. This is a solution. You can verify it again. Oh, it's just a linear. First order linear. You can verify it again. This is a solution. Let's work out it with that solution. Then you need to find the maximum. Y dash. Find the y dash first. Y dash is equal to 2 into t plus 1 e raised to t by 2. Y double dash 2 minus et by 2. Maximum. You need to find the maximum of this curve. 2 minus mode function. This is one of the mode function. Modulus of maximum of modulus of 2 minus et by 2. Just I am plotting this one. If whenever t equal to 0, 2 minus 1 by 2. Point become equal to 0, comma, if t equal to 0, 2 minus 1 by 2. 3 by 2 will come. Then this curve, if equal to 2, if equal to 2, this is whenever 0, 2 means here. This is a decreasing function. Decreasing function. Differentiate it. See the differential of this. E raised to t by 2. So always less than 0. It's a decreasing function. So it is decreasing. And you have to reach whenever 2, 0 to 2. You need to find up to 0 to 2. 2 comma 2 minus e square by 2. See, you are finding the modulus of that. So this curve, you have to plot like this. See, up whenever 2. 2 means whenever 2, this is negative of that. Negative of that means e square by 2 minus 2. E square by 2 negative. This is the maximum. E square by 2 minus 2. That is the maximum. M equal to e square by 2 minus 2. See, this is your M. Because this is a decreasing, you need to find a modulus. So you just plot it here. So here it is negative. So positive, you will come e square negative of 2 minus e square by 2. Sorry, 2 minus e square by 2. That means e square by, this is a negative value. E will, we know 1.70 something. So positive of that, e square by 2 minus 2. That is m. That means e square by 2 means 0.5 e square negative 2. Now you can find the error bound. You find all the values. For all the needed values, you find it. Now use the equation and found out the error bound. Okay. Error bound. mh into 2l. M means 0.5 e square minus 2. That is m. H equal to 0.4 is clear. Divided by 2l. 2l is nothing but l is 1. Lipschitz constant 2. E raised to l is again 1. Ti, where you are going to find 0.8 up at 0.8 minus a value. A is 0. A is 0 by minus 1. Minus 1. That equal to, this is the error bound. That equal to 0.4 by 2, 0.2. 0.2, 0.5 e square minus 2 into e raised to 0.8 minus 1. Yes, this is the answer. Is it clear? Which is the option? Let us see the option. 0.2, 0.5 into e square minus 2, e raised to 0.8 minus 1. Yes, option C is correct. Clear? So just understand that error bound. Just remember that error bound. Okay, fine. Is it clear? Hello? Is it clear or not? Hello, please respond. Is it clear?
Yes, sir.
Hmm? Okay. Then we will move to this problem. 1 to 2 questions we will do it and we will wind up. Don't worry. The remaining problem you can solve it. If you have doubt, you can contact me. For h greater than 0 and alpha, beta, gamma belongs to our let dh f of a is given. We have 3.4 lakh to approximate f dash of a for any differentiable function. F from R to R and a belongs to R if dh f of a equal to f dash of a. For every polynomial f of degree less than or equal to 2 and for all a belongs to R. Then, okay, so they are given that dh f of a equal to f dash of a. They are given like this. And they are given a belongs to R. Just I am going to take a equal to 0. Now, up to degree 2 less than or equal to 2. First I am going to take f of x equal to 1. Constant polynomial. So you have f dash of x is equal to 0. So f dash of 0, f dash of a already we are considered as a 0 only. F dash of a equal to 0 only. So left hand side, dh f of a equal to f dash of a. That equal to 0, 0 equal to a into f of a minus h. Alpha into a you consider as a 0. F of 0 minus h. F of negative h. Anyway, the 1 only. F of negative h. F of x is 1, correct? F of negative h. Yeah, is 1 only. Alpha plus. Second also beta. F of a is 1. Plus gamma. Whatever it is, f of x is 1. So alpha plus beta plus gamma by 6h. From that, you will get it alpha plus beta plus gamma equal to 0. This is equation number 1. Now you take f of x is equal to x. Second, up to polynomial of degree 2, f of x equal to x. F dash of x is equal to 1. So 1 equal to alpha a0 f of negative h. So you will get minus h plus beta into f of 0. F of 0 is 0. So that term is gone. Beta into 0 plus gamma into f of a plus 2h. A is 0, f of 2h is become 2h by 6h. From that, what you will get? H cancel. 6 is equal to 2 gamma minus alpha. Now you take f of x is equal to x square. Derivative is nothing but 2x. F dash of a equal to, then again f dash of a you are considered as 0. So f dash of x is 2x. F dash of 0, a you are considered as 0, right? 0 only. So that side is 0. Alpha into negative h. A is 0, negative h whole square. Alpha h square. Plus beta into 0. 0 square, 0 only. Plus gamma into 2h the whole square. That means 4h square by 6h. Then, yeah, you can cancel h. 0 equal to alpha h. H you can take as a common. Plus 4 gamma. 6 you can take the left hand. Alpha plus 4 gamma equal to 0. Alpha equal to minus 4 gamma. 6 is equal to, so 6 is equal to 2 gamma minus alpha. Alpha means negative 4 gamma. 6 is equal to 6 gamma. Gamma equal to 1. So alpha equal to minus 4. Gamma equal to 1. Alpha equal to minus 4. So beta. Now you need to find the beta. Minus 4 plus beta plus 1 equal to 0. Beta equal to minus 3. So plus 3. You need to find the value of, I think need to find a value of, okay. Let us see options. First option. Okay, whole value you got. Alpha equal to minus 4. Gamma equal to 1. Beta equal to 3. So let us verify the option. Alpha plus 2 gamma. It means minus 4 plus 2 into 1. 2 is equal to minus 2. It's not minus 2. Option 1 is correct. Alpha plus 2 gamma equal to 2. Option C is incorrect. Option A is correct. Option C is incorrect. Alpha plus 2 beta minus 2 gamma. Now let us verify. Minus 4, 2 beta. 2 beta means 2 into 3. Minus 2 gamma is negative 2. Minus 6 plus 6 is equal to 0. Option D is incorrect. Option B is correct. So option A, B are correct. A, B are correct. Is it clear? Yes or no? Is it clear? Yes? Okay. Next. I think the 9th question is from GATE. Numerical value type. Up to all of CSIR. Now this just from GATE. Okay, what's the question? For a fixed C belongs to R, alpha is equal to integral 0 to 2 9x square minus 5cx x raised to 4 dx. The value of 0 to 2 9x square minus 5c x raised to 4 dx obtained by using the trapezoidal rule is equal to alpha, then the value of C is equal to round off 2 decimal places. Okay, anyway. We know the formula for two-segment trapezoidal rule. Integral a to b f of x dx is equal to b minus a by 2. That means h by 2. F of a plus f of b. So just a 2-point f of a plus. Just I am going to see the two-segment trapezoidal rule for integration. So that value is alpha. Alpha equal to b minus a, 2 minus 0, 2 minus 0 by 2, f of 2. F of a means f of 0, f of 2. 2 by 2 is 1. F of 0 plus okay, that equal to f of 0 plus f of 2. F of x is 9x square minus 5c x raised to 4. So f of 0 becomes 0. F of 2, 9x square. 9 into 2 square is 4. 36 minus 5c x raised to 4. 5c into 16. 16 into 5. 80.
Excuse me,
80c. Yeah.
sir, why you take 2-point only?
I'm not getting. Tell me.
Why you take 2-point formula?
For easiness. For easiness. You can take more also. But they are just telling trapezoidal rule. So just I'm going with for an easy calculation. That's it.
Okay.
Okay. Yeah. You can take no issue. But for for my convenience, I'm going to see the easiness. 36
Okay.
minus 80c.
Okay.
Okay. That is the left hand side. Okay, then and one more. You can calculate directly also. Then what you will have? Alpha is equal to integral 0 to 2 9x square minus 5c x raised to 4. So the value of alpha is equal to 0 to 2. Okay, just go with integration. Nine x cube by 3 minus 5c x raised to 5 by 5 from 0 to 2. Apply it. 9 by 3 is 3. 3 into 2 cube, 8. 3 into 2 cube, 3 into 8, 24. 24 minus 5 cancel. 2 raised to 32c. Now equate these two. 24 minus 32c. 12. You take here 48c. C is equal to 12 by 48. 1 by 4. 0.25. Correct? Is it clear? Is it clear? Okay. Yeah, we will move the last problem. With this, I will wind up. With this, I will wind up. Remaining 5 questions, you can solve it. If you have a query, you can ask in WhatsApp itself, or my number I will provide there. Don't worry. A Rangakuta method for solving dy by dx is equal to f of xy. Yeah. RK method for solving dy by dx is equal to f of x comma y y of x not equal to y. Is given by y of x plus h. Y of x plus h equal to y of x equal to W1 F1 W2 F2. F1 equal to, these are given from the question, h into f of xy, F2 equal to h into f of h into f of x plus alpha h y plus beta f1. Okay. This is given from the question. These are given from the question.
Hello, sir.
Yeah.
So is the RK2 method constant we are getting? That alpha is equal to 1 by 2 and beta is equal to 1 by 2?
Yeah. Correct. The generally I am now I am going to tell you. These all are given from the question only. Whatever written, we got from the question. Now, whatever the theory we know, that I am going to write now. Okay. Hello.
Yes, sir. Yes, sir.
Yeah. That I'm going to write now. Okay. Generally, second order Rengekutta method, yn plus 1 equal to yn plus 1 is equal to y plus 1 by 2 into k1 plus k2. Correct. Yeah, k1 plus k2. More generally, you can written as y plus more generally w1 k1 w2 k2 or you can write this like this also, y plus 1 by 1 minus 2 alpha k1. This is from theory of Rengekutta method. 1 by 2 alpha k2. More generally, for that, for easy formula, this is the most easy formula. Yn plus y equal to y plus 1 by 2 into k1 plus k2. K1 is nothing but
Sir,
h into, yeah.
so in the second line, you are writing the formula that yn plus 1 is equal to y plus w1 k1 plus w2 k2. I think the second part, that is w1 k1 plus w2 k2 divided by w1 plus w2.
W1, tell me again.
Plus, that means in the second quantity, except the y term in the equation, the next term should be averaging to 1. So that w1 k1 plus w2 k2 divided by w1 w2. Is it right?
W1 k1 w2 k2 divided by w1 by w2, right?
w1 plus w2. Well, entire thing.
Anyway, that is constant, right? That is constant.
Yes,
that
sir,
constant,
yes, sir.
That constant you can take from the linear combination.
Okay, sir.
Yeah.
So that we need to some additional condition that w1 plus w2 is equal to 1.
Yes, correct. That I am going to tell you next. Yes, that is correct. Yeah. K1 into hf of t comma x. If you are in t and x, or here it is, I think x comma y. Just I am writing t comma x. That understood from the theory. H into f of t plus alpha f plus x into beta k1. That is a general theory. And this most general you can take in terms of x. X I am writing x of t plus h. X comma t I am writing. Y comma x. X of x comma t. x of t plus W1 h into this k and k1 and k2 I am writing here. T comma x W2h W2h f of t plus alpha f x plus beta k1 is equal to hf plus order of h cube. Order of h cube we are removing. Anyway, now this is the condition. What he told, that is correct. Very clear, very good one. W1, W2 always equal to 1. Yeah, W1, W2 always should be equal to 1. And one more formula, W2 alpha, this is one condition, W1, W2 should be equal to 1. And another one, W2 alpha equal to W2 beta equal to 1 by 2. That we can analyze from the second order 𝔸𝕑 method for easy formula from this. W1, W2 equal to 1. W2 alpha, W2 beta should be equal to 1 by 2. And more necessary condition is nothing but alpha should be equal to beta. These also 3 conditions. So just understand these 3 conditions. That is enough for you. One is W1 plus W2 should be equal to 1. And alpha should be equal to beta. W2 alpha equal to W2 beta equal to 1 by 2. Use this condition and you can neglect the options. W1 plus W2. Yes, first option, let's see. W1, W2. Correct. First option, W2, W1 is equal to 1 only. And alpha equal to beta equal to 1. Correct. The 3 conditions are satisfying. From this, you are able to see that alpha should be equal to beta. These 2 conditions are same only. Alpha should be equal to beta. Correct. Option 1 is correct. Option B is incorrect. W1 plus W2 is getting 3. C. Yes, W1 plus W2 is equal to 1 only. Plus alpha beta equal to 3 by 4. Correct. Option C also correct. Option D. W1 plus W2 is equal to 1. Correct. Alpha beta equal to 2. So option A, C, D are correct. Option B is incorrect. So this is the just condition. Should W1 should be equal to 1 and alpha should be equal to beta, and this is the most general formula for ℸ𝕑 method of order 2, because we are neglecting the order of h cube. I think this is the time for wind upping, or I need to go a little bit more. Is it enough? Enough,
Yeah.
sir?
Yeah, thank you. Thank you,
Yeah.
Rafeek.
Yeah.
The other problems can be attempted by themselves, and if they have any
Yeah.
doubt, they can ask in the group.
Yeah.
Okay. Thank you, Mr. Muhammad Rafeek, for spending your time with our group and discussing a lot of good collection of problems from the area of numerical analysis. I'm sure that those who have attended the session will definitely get benefited out of this in their forthcoming examination. Dear participants, now it is your time to express your feedback, share your feedback, and if you have any queries, you can ask it. Yes. Yes. Yeah.
Good evening, sir. I am Shikha, and I have just completed my course, that is Integrated MSc Mathematics and Computing from Birla Institute of Technology, Mehra, that is in Jharkhand. So your session was really very wonderful, since it's a very small topic and you just not that small, but it's a vast topic, but the marks that it covers it's small, so you just covered the whole topic in a very small interval of time and in a very precise manner, sir. It was really wonderful, and I'm sure that it will help us a lot.
Thank you. Thank you.
Thank you,
Yeah,
Vinod, sir.
Yeah, thank you. Thank you, Sika. Yes, others. Okay, dear participants, feel free to share your feedback. You can keep your video on and introduce yourself first. Yes. Hello. Yeah, Sneha.
Good evening, sir. I'm Sneha Shodhar, and I'm pursuing my MSc from IIT Bhubaneswar. And sir, today's class is very interesting, and everything is very clear to me now, because I think numerical analysis is a very tough topic, but class is very interesting, and I understand everything very clearly. Thank you, sir.
Thank you.
Thank you, Sneha. Any others? Yeah, Dharmendra.
Hello, sir. I am ℕ𝕦𝕞𝕤 from Delhi. The problem was very nice on that topic, and some problems are new for me, and some are very interesting. Can you tell some your PhD experience, sir? And
Yeah.
some
Yeah.
reference books also.
Yeah, I am working on two areas. One is on mathematical theory of control, and another one is hydrodynamic stability. The control theory, especially I'm working on multi-agent networks. In that we are using linear algebra, ordinary differential equation, and graph theory. We are focusing on the controllability, observability, like that concept of properties of differential equations. Then we published one paper on that. The paper's name is on the theory of nearest neighbor connection of multi-agent networks for the normalized Laplacian, that you can available in the website. That is Bulletin of Iranian Mathematical Society. That is a one field, and some of the research works are under review now. That may come in soon in the online. That field is really good, mathematical theory of control, and is new emerging field of mathematics. Especially very less people are working in that. Control theory, some of the classical control theory, some of the people are working. But this control theory of multi-agent networks, see, in our physical world, there is lot of networks. In that networks, we are considering some of them as a leaders, some of them as a followers. Then we are able to reach the desired final state. Such a type of property we are seeing in that control theory works entirely with mathematics. And another one is hydrodynamic stability. That is a branch of computational fluid dynamics, or CF, fluid dynamics. In that also, now we are published around 3 to 4 works. So some 6 to 4 works are under review, and some under processing. So in that also, we are using the functional analysis concept, and some of them really ordinary differential equation we are using, and partial differential equation we are using. And it is like a there is some flow in that. If some perturbation is happened to flow, is still that flow becomes stable or unstable? So what is the condition for that? Such a type of things are doing in that. And especially that also, fluid dynamics is working in mathematics peoples, mechanical engineering people, different streams of engineering peoples. And especially once come to the computational fluid dynamics, mainly mathematicians are working. And after that, in that also, this hydrodynamic stability. There, what is the thing? First, we have the partial differential equation, highly coupled partial differential equation. One thing, we are not going to the solution of that. For solution, we have such a type of approximate methods like finite volume method, finite difference method, and finite element method. But here we are going to see the when the system becomes stable, unstable. For that condition, we are going to find. For that, we are using mainly functional analysis like calculus of variation, maximization, minimization problems we are using, and we are finding that condition. Like such a type of work is doing in that. Some of the paper is published in that also.
Thank you, sir.
Yeah. Thank you.
I'm Zahra Rumaisa from Kerala. Today's session was really nice. The way of solving problems and explaining topics are really interesting and very helpful to understanding. And thank you, Vinod sir, for conducting such a nice session. And thank you once again, both of you.
Okay, thank you, Rafeek.
Yeah.
Thank you very much for this session.
Thank you, sir. Thank you.
Let us wind up here. Thank you.
Yeah. Thank you, sir.